first fifth lecture and the third lecture about the material removal technologies. Okay. Okay. Guess what is the content of the lecture? So we will discuss about the tool geometry and inserts, about the inserts. Okay. So am I audible? Okay, so let's start. So yeah, so this is the acknowledgement, and this is the content of the material removal technology. So we already covered the classification of type of machinery and accessories and tooling and jigs and fixtures. So today we'll discuss about the tool geometry. Okay. Okay. Then yeah. So can you do you have any idea? So why we important the tool geometry? So can you put a message in chat box? So why it's important about the tool geometry? So please rename your name using your index number. What is the tool geometry? So have any idea about tool geometry? Yeah, why it's important? The importance of the geometry? Yeah, structure of the tool. So others? So yeah, so when you consider about the tool geometry, the angles and edge features, it's decide the chip flow, also heat and the forces and the finishing of the surface, and also it's consider, also it's decide about the tool life. Okay, so when we use some tools in the manufacturing removal processes, basically we have to consider about the tool geometry. Okay, then let's move. So the modern machine tool have the capability of rapidly producing extremely complex part geometries. The program controlling a machine tool can incorporate changes in cutting condition and compensate for tool wear, automatically change tools and machine a workpiece without refixturing or transferring it to another machine tool, as had been the practice for many years. So as example, when we consider about the CNCs, it can change speed, feeds and tool automatically, but the geometry is very important. Okay, so yeah, so if the edge shape and angle don't match the material and operation, the program can't save you. Okay, so you will get chatter, BUE or rapid wear. Okay, so that's the importance of the tool geometry. Okay. Then the introduction, the traditional method of machining parts by using different types of machine tool has been and continue to be a viable and efficient manufacturing method. Okay, so when we do the practicals in the workshop, you may you I think you had the experience in lathe machine. So you when you do the turning and facing, likewise the manufacturing work process, you can experience those things. Okay, then it can be highly automated in order to increase productivity, and it is indeed a principle behind transfer lines, also called dedicated manufacturing lines or DML. Okay, then the commonly used in high volume or mass production, transfer line consists of several specific machine tools arranged in a logical sequence. Okay, and the workpiece, such as an automotive engine block, is moved from station to station with a specific machining operation performed at each station, after which is transferred to the next machine for further specific machining operation. Okay. Uh, then the Yeah, so also in here, explain about the tool geometry. So there are situation, however, in which transfer line are not feasible or economical, particularly when the type of products to be proceed change rapidly used to factors such as product demand or changes in product shape or style. Okay, so it's very expensive and time-consuming process to rearrange these machine tools to respond to the needs for the next production cycles. Okay, so when we discuss the next slide, so these things we will discussed. Okay, an important concept that decrease flexibility in manufacturing developed in the late 1950s is that of machining center. Okay, then the machining centers. A machining center is an advanced computer control machine tool that is capable of performing a variety of machining operation on different surfaces and different orientation of a workpiece without having to move it from its work holding device or fixture. So when we consider about the machine, so like this machine, yeah, you can see the machine holder and machine bed can move with axis. So there is a three axis, X, Y, Z axis. So you can see in this image, Yeah, and we yes, you can see in here. So this machine bed can move this yeah use this part can move along the x-axis. Okay, so this workpiece we can move along the y-axis likewise, so it can be rotated likewise. Using the three-axis we can move uh, match the machine tool holder, also the workpiece. Okay. Okay. Then the workpiece generally is stationary and the cutting tool rotates as they do in milling, drilling, honing, tapping, and similar operations. So you already experience milling, drilling, and tapping these operations. So you have to remember. So what about the working principle when we do the when you do the this machine operation? Okay, so we are in transfer line or in typical shops and factories, the workpiece is brought to the machine. In machining center, it is the machining operation that is brought to the workpiece. Okay, then machining centers. So modern machine centers are really advanced. They are usually equipped. So these things you have to get some idea. So there is a small video clip. Okay, so this one you can see the after the lecture. So you can see yourself this video. Okay. Okay. When we consider about the classic transfer line vs machine center, so in high volume transfer lines, each station does on OP. Okay, in machining center, we bring multiple OPs to the client work. So in the one setup, you can use many tools that puts pressure on choosing the right insert geometry for each OPs. Okay. Okay. Then we can move. So yeah, then the tool geometry. Okay, so yeah, so yeah, so cutting tools for metal cutting have many shapes, each of which are described by their angles or geometries. Every one of these tool shapes have a specific purpose in metal cutting. The primary machining goal is to achieve the most efficient separation of chips from the workpiece. For this reason, the selection of the right cutting tool geometry is critical. Okay, then what the tool geometry means, the most metal cutter uses single point tool like turning and facing process. So we describe the tool by angle measured on the shank's axis. Okay, then the after mounting the holder, the effective angle seen by the work can change. So holder style and lead angle is matter. Okay. Then yeah, so you can see in here. So there are so many angles when we consider about the cutting tool. So the major Majority of metal removing operations involve the use of simple single point cutting tool with the geometry of a typical right hand cutting tool shown in below figure. So in here mention right hand cutting tool. It means they also have a left hand cutting tools. Okay. Okay, there are exceptions which does not use angle point cutting tools such as drilling. So you can see, yeah, there is a when we consider about the cutting tool, so you can see the shape of the cutting tool. So this is not a cutting point. So there has a cutting edges. Okay, so there is a the cutting edge have very small radius. Okay, so this is not a point. Okay, so when we consider about the geometry of this cutting tool, so you can see there is a side rake angle. So this part we known as a shank, and this side face we known as a flank face. Okay, so this part, yeah, yeah, uh, this part we can known as a shank. In here you can see, so in here you can see this is a shank, and this face we known as a flank face. Okay, okay, so you can see the between this surface and this surface there is a some angle shape. It's known as a side rake angle. Okay, so when you see the cutting tool, you have to identify these angles. In here mention angles, you have to identify using the real time tool. Okay, so there's a I think 7 angles, side rake angle. So this is the in cutting edge angle, and there's a clearance or entry leaf angle, and yeah, in here side angle. So these things we will discuss in the next slide. So yeah, you can see this one. This is the tool holder. I think I am audible for you. So yeah, can anyone put a message? Am I audible? Can you hear me? So can anyone? Okay, okay, thank you. Okay, so yeah, so okay, so yeah, wait. As example, yeah, no, in here there's no image to show you this part. So this one we known as a tool holder. So this is the tool clamp screw, and this is a tool clamper. So this is the insert. So in here we put our tool, and this part we known as a seat or shim. Okay, okay, okay. So in here, yeah, uh, this using that images in here. In detail, 2D drawings are shown in here about the this cutting tool. Okay, so yeah, right. now I think now it's fully clear. Okay, so yeah, this is the object of this 2D drawing. Okay, so the yeah uh, this uh, okay, this is the direction, maybe direction. Okay, so this is the end view. So this is the this face we known as a shank, and this face we known as a flank face. Okay, so in here mentioned. So the using this line, this line, it's mentioned about the shank surface. Okay, then using this angle shape, it's mentioned about this surface. Okay, I think it's clear to you. So the between these two surfaces angle is we known as a side rake angle. Okay, so it's mentioned in here. Okay, uh, short name is RA, and the angle between this side surface and this side surface we known as a side relief angle. Okay, so in here, it's also mentioned about the side relief angle. Okay, then let's read the content. The various angles in a single point cutting tool have important function in machining operation. These angles are measured in a coordinate system consisting of the three major axes of the tool shank. So the three major axes is X, Y, Z axis. Okay, then the note, however, that these angles may be different with respect to the workpiece after the tool is installed in the tool holder. Okay, the tool holder means this part. Okay, then let's talk about these tree view, about the tree views. Okay, so this is the end view. So it means the weaving direction is this direction. Once you see using this direction, the 2D view, it should like this. Okay, so using this is the tool edge. Yeah, you can see using this part. Yeah, you once you see the tool, you have to identify these mentioned angles. Okay. Okay, then the side view. Okay, it means the viewing. This is the direction. Okay, so this is the shank part. Sorry, and this is the flank face. Okay, so this angle known as a wedge angle, and this angle mentioned as a back rake angle. So this small angle known as a back rake angle, and this angle known as a end relief angle. Okay. Okay. Then the top view. Okay, so you can see this is the cutting edge. It's not like this. It's not a point. It has very small radius like this. Okay, so this radius we known as a nose radius. Okay, then the this small angle known as a end cutting edge angle, and this angle known as a side cutting edge angle. Okay, so you have to know about these all geometries once you see the cutting tool. You should have to identify these all things. Okay. So I think you are clear until this point. Have any question until that point? Then after that we will going to discuss about the angles one by one. So have you any questions until that point? Uh, so now it's right. Am I audible or am I clear? So which point it's not clear? Which point? Do I need to explain again this one? Can anyone unmute your microphone and give me the answers? So do I need to explain again this part or it's clear? මම තේරුණාද මොකද අයිමන් මේ ටික කියන්න ඕනද? Okay, then we can move. Yeah. Okay, then the rake angle. Okay, so rake angle. When we consider about the rake angle, there is a two type of rake angle, the positive and negative rake angles. Okay, so rake angle is important in controlling both the direction of chip flow and the strength of the tool chip. Okay, so yeah, let's see. So when we consider, yeah, in here, so this is the rake angles. There is a angle type, so back rake. So when we consider about this part, so this is the rake angle. Okay, so you can see yeah, in the below it's mentioned the rake angle is this one. So when we consider about the rake angles, there is a positive and negative rake angle. So positive rake angles mean when we consider about the x-axis, this part side angles we known as a positive rake angle, and the angle it goes to this side we known as a negative rake angles. Okay. Okay. Then the positive rate angles improve the cutting operation by reducing forces and temperatures. However, positive angles also result in a small included angle of the tool tip, possibly leading to premature tool chipping and failure, depending on the toughness of the tool material. Okay, so yeah, when we consider about the positive and negative rake angles, so the positive rake slices is easier and it should have a lower cutting force also lower temperature and it has a nice chip shape. Okay, then the but it thinks the edge. So it's leaker and can chip if the cut is rough or interrupted. Okay, then the negative rake strengthens the edge and the tolerate shocks, but increases force and heat. Choose based on material and rigidity. Okay. Okay, so if there is a negative rake angle, the material or the cutting tool life can be minimized. Okay, so yeah, okay, so the cutting tool we feed move to this direction, and the workpiece direction is this direction, and this is the chip flow. It goes to this direction. Okay, so yeah, when if the rectangle is negative, the cutting chip thickness is very low, but the uh, this part goes to minimize. Okay, so and this the negative rectangle can be damaged this cutting edge. Okay, so that is the disadvantages of the minus rake angle. Okay, then the next one, side rake. The side rake angle is more important than the back rake angle, although the latter usually control the direction of chip flow. Okay. For machining metal and using a carbide range from minus. Yeah, so there is some internet issues. I think I'm clear for you. For machining metal, so yeah, is that mean? Yeah, the side rake. So when we compare the side rake and the back rake, the side rake has the bigger, say, in chip thickness and flow, and the back rake is still chip direction. Okay, so for many carbide inserts, these are often small, around minus 50 degree to plus uh, minus 5 degree to plus 5 degree, because inserts get their effective rate from topography. Topography means chip breakers. Okay, then if chips are sticking, try more effective positive rate. Okay, if the edge is too fragile, it's back. It's back off. Okay. So yeah, using this image again, it's mention the all angle shapes. Yeah, the faces, cutting edges, battery angle, nose radius, and flank. Likewise, it's again uh, mention the full details. Okay, then the cutting edge angle. This is the angle between the main cutting edge and feed direction, around 15 degrees common, and the larger angles lay the chip out and reduce radial forces. Okay, the smaller angles push more into the work and can help it tight shoulders. Okay, then it's also influences chip flow of the tool and end to shock. Okay, then let's see. Yeah, the cutting edge and angle affect chip formation, tool strength, and cutting forces in various degree. Typically, the cutting edge angle is around 50 degrees. Okay, so I think you can clear this one. And the relief angle. Relief angle controls interference and rubbing at the tool workpieces interface. If it is too large, the tool tip may chip off. If it is too small, flank wear may be ex- uh, excessive. Relief angles typically are 5 degree. Here, relief yeah, when we consider about the relief angle, relief prevent the flank from rubbing the fresh surface. If it is too small, the flank wear.
Recording stopped. Recording in progress.
So it's my, I think my internet connection is not stable. So am I audible? So can anyone tell me, am I audible? So uh, yeah, then yeah, can you see my screen? Can anyone tell me which point I'm disconnect? මොන තැනේදීද මම disconnect උනේ? Is it clear about the cutting edge angle? And that I think at that point we will discuss about the relief angle. Okay, so I think it's clear for you. So again, yeah, okay. Yeah. Okay, so the relief angle prevent the flank or rubbing the fresh surface. So I already told you the if the relief angle is too small, it means that there is a flank wear and heat. If it is too large, it means there's a tip becomes fragile and can chip. Okay, so yeah, so the starting point, typical starting point of the relief angle, we can mention as about 5 degree. Yeah, so okay, then the nose radius. So nose radius means there is a the the cutting edge. It's not point like this. It's not sharp. There, it has the cutting edge has a very small radius like this. So this radius we know as the nose radius. Okay, then the nose radius affects surface finish and tool tip strain. The smaller the nose radius, the rougher the surface finish of the workpiece and the lower the strength of the tool. However, large nose radii can lead to tool chatter. Okay, so when we consider about the nose radius, radius trace finish vs stability. The bigger radius mean the stronger corner and smoother finish we can generate, but there can be a chatter on light limb setups because it raises radial force. Okay, then the smaller radius cut lightly and it it is good for fine features, but it's leave a rougher layer and is weaker. Okay, for finishing steel on a rigid lathe, we can mention zero point 0.4 to 0.8 millimeter in a common sweet spot. For light benches, go smaller. Okay. Okay. So in below image, the mark the chatter marks and free zone. Okay, you can see this one. Since a sharp edge is weak and fractures easily, and insert's cutting edge is prepared with particular shapes to strengthen it. Those shafts include a horn radius, a chamfer, a lat, or a combination of three. So we already discussed this one. Insert size is designed by the largest circle which can be inscribed within the perimeter of the insert called the uh, inscribed circle. Insert size is directly connected to the tool holder size. Okay, so now you know about the geometry of the tool holder. Okay, so yeah, uh, yeah, you can see in here some of tool shapes are applications are shown in the figure. Yeah, uh, like so what is the material removal processes we used to do like this shape? Yeah. uh, yeah. uh, can you tell me so what is the name of the manufacturing process if we use like these tools to change the diameter of like this workpiece? So what is the name of the process? Can anyone tell? Process is turning. Okay, so if we are going to make a surface, it means facing, and if we are going to change the diameter size of the workpiece, it's known as a turning. Okay, so when this is the sum of turning shapes, so you can use like these geometry cutting tools to do these uh, to manufacture these processes. Okay, there's some screw shapes. So and like these shapes, if we need to um, manufacture or make like these shapes, you have to select like these tools. Okay, so if we need to do facing process like this part, you have to use like this uh, tools like with this geometry. Likewise, we have to likewise in here mentions about some cutting tool geometries. Okay, so cutting off, back turning, grooving, front turning, threading, and boring. Okay, so these are the some examples to the tool geometry inserts. Okay. Yeah, so yeah, so in details on here mentioned Chipro clearance, and this is the radius, secondary rake, primary rake. Okay, so horns. So you have to identify those things once you see this thing. So this is the tool holder. So in here, yeah, you can see we insert the cutting tool for the insert part. This is the holder cylinder part. Okay, so when you do the practicals, uh, you can identify these things. Okay, so yeah, in here mention about the vary of the increase strength with the angle shape of the cutting edges. Yeah, so you can see the strength of the cutting tool is increased with the angle of this angle of this surface. Okay, so yeah, these are the basic carbide insert shapes. Strength of the insert increase as corners increases in the angular value. The round insert is strongest. Okay, so okay, so until that point, have you have any question until that point? Then okay. Yeah, insert type tool holder for turning consists of a shank, heat, insert pocket, and clamping hardware. Tool holder are either right or left-handed or neutral. Okay, then the size and the type of the tool holder are determined by. So these are the point you have to think about: the turning operation, feed direction, size of cut, and machine tool design, and the need of accessibility of shape of workpiece. Okay. Then the insert size is given by the large. So yeah. Turning holders. When we consider about the tool holders, the turning holders can be right hand or left hand or neutral. Speak based on the feet direction or shoulder approach and chip regulation. So holder geometry, uh, you can change if with effective rectangle and relief. So you can choose holder size for rigidity and machine in and access to features. Okay. Okay, so yeah. Okay, then this is the end of today's lecture. So if you have any question, now you can ask. Or if you need more explanation in any slides, you can tell me. Is it clear these things? So you should have to identify all the angles once you see to select the cutting tool in your material removal processes. So like this with the shape, the tool varies. So to select the tools, you should have to know about the suitable tool geometry. Okay, so have you any question? Or is it clear? So please tell me. I need your comment. So if you cannot uh, unmute your microphone, please put a message in the chat box. Yeah, okay, then others. So yeah, and I'm planning to do another practical session, and we will start that part once you come to the university. So yeah, and that practical session you can uh, clearly identify these or get a hand-on experience about the two geometries. And in that practical, I will give you some more explanation uh, using tools at the workshop. Okay, so if you cannot understand at that point, you can ask the questions at the practical session. Okay. Okay, it's better if you have any problem or if you need any clarification, you can ask at that point. If you cannot ask that point, you can ask about these things at the practical session. Okay, so at the practical session, we are going to manufacture some workplace using various manufacturing processes, and we will give you one workpiece for 5 members, and you have to manufacture the given design using machines. So you have to do that one in yourself as a group work. And once you do the practical, you have to make a report. And yeah, there is a individual evaluation report evaluation. But the workplace we should have to manufacture as a group work. The group have 5 members. So okay, so if you haven't any questions, yeah,
Recording stopped.
okay, I think it's all clear about it's all clear to you. So yeah, then if you haven't any question, we can wind up today's session. Okay, then thank you for joining. So until we meet up, we will do online lectures. Yeah, okay. Stay safe and goodbye.